Hello, my 9th standard students. Okay, have a nice day. Good morning. Okay, this is little Raj from Cochin, Kerala, signing in from this part of the world. So, my dear kids, so we are going through the 9th standard science. I think it's first chapter, and the name of our chapter is it's a part of chemistry, matter in our surroundings. So, the last three classes we already discussed about a lot regarding the matter. So, in common word, what is a matter? Matter, anything which occupies space and has a mass. Okay, for example, a piece of rock, a pen, a glass of water, a stack of air and all. Everything is matter in this world. So, in the last class we discussed about three different main properties of matter. That was about solid, liquid and gas. Matter exists in three different states according to modern science. And solid, liquid, gas. Solid, high density, liquid, medium density, gas, very low density. And if we zoom in with a microscope, we can see solid surface like this. Means the particles are closely related with each other. At the same time, liquid, there will be some space in between those particles, and in the case of gas, it will be very free to move here and there. In the last class we already did lots of examples regarding all these things. So now next part we are going to study is about changing of these states. Last class you studied about properties of gases, properties of solids, properties of liquids, isn't it? In that properties we studied one word called as diffusion. I told we will discuss about diffusion in the next class. Actually, diffusion means is nothing. Okay, I told that when you enter your home and your mother is cooking something in the kitchen, by sitting in the drawing room itself, you will have the sensation of the smell coming from the kitchen. Why? Because the air molecules will travel through the atmosphere, isn't it? So, the fragments of that curry, whatever your mother is making, it will spread throughout the atmosphere there, and it will fill the air molecules in the atmosphere and it will reach our tip of the nose. So that process is called as diffusion. Moving from a place where there is higher concentration to a space where there is less concentration. Understand? Moving from a place when high concentration to a place of less concentration. And we can discuss about this with an example. Have you seen syringe? If you go to hospital, you can see doctors will inject with that syringe. Okay, you are very well familiar with that syringe, isn't it? So I need 3 syringes. Okay, you need to make 3 syringes and not want to make, you want to buy it from any shop or any old syringe is also fine. In one syringe, what you want to do? You want to fill sand. The second syringe, you want to fill water. And the third syringe, you don't want to fill anything. If you are not filling anything, automatically air is inside that syringe, isn't it? And I want you to close the other tip or other nozzle of that syringe. So syringe has one opening at the front, where that doctor fixes that needle and he punches our body and injects medicine into our body, isn't it? So I want to close that tip. You must close that tip of that syringe. Now you have 3 syringes in your hand, isn't it? 3 syringes. One filled with sand, one filled with water, one filled with air. Am I right? You want to use maximum force so that you press that piston. That piston is there, which will push us inside like this. If it's a syringe means we can push that piston inside. Am I right? So you have 3 syringes, one with chopper, one with sand, one with water and one with air. So in those 3 pistons or 3 syringe, which piston you will be able to pull or push the most? In which cases the piston will move more? Is it regarding sand? Is it regarding water? Or is it regarding that air? 100% the syringe in which there is nothing. That means the syringe in which air is there, that will move more, isn't it? So, the last class we discussed that. Air is very easy to compress. Liquid Medium compression, solid, almost impossible to compress most of the solid, almost impossible. Some solid we can compress, for example sponge. We can compress some solid, but the compression rate is very low for solid, medium for liquids, and very less for gas. At the same time, the distance between the particles is very high in gas, medium in liquids, and very low, very small in the case of solid. So these were the different properties of matter. And now next what we are going to study is change in state. Okay, change of state. Three different states are there: solid, liquid, and gas. Liquid, any example? Tell me. Water, gas, okay, LPG. So change of solid. So change of matter, change of matter. So how is it possible to change this matter? How? A common example we can give. A common example. This is about changing the state of water. You already know that water exists in three different states: solid, liquid, and gas. When it comes to solid, what we can say? It is ice. Am I right? Ice. Solid is ice, liquid is water, and gas is what? Water vapor. I think you understand or not, I don't know. Okay, fine. Three solids, or three states of matter of water is: liquids form, it exists as water. When it solidifies, it becomes ice, and next it becomes water vapor. So water vapor is gas, water, the common water is liquid, and the ice is solid form of water. So how we can change this matter, the properties of matter, into different states? How is it possible? Commonly, simply placing the water, it will become ice. Now we need to do something, isn't it? We need to do something. So let's see. When a solid is heated, it changes into liquid, and when a liquid is heated, it changes into gas. It's a common thing, isn't it? If we have ice, if we heat the ice, it will melt, it will fuse to become liquid form. And when we again heat that liquid, called that water, what will happen? It will become water vapor. Common thing. It's a very common example. Am I right or not? All of you know that. I already all know that. And when gas is cooled, it will become what? It will become back to liquid. And again, when it is freezed, when this water is freezed, what will happen? It changes into ice, isn't it? So let's see, we can see a simple cycle regarding that. Solid, liquid, and gas. But to make solid to liquid, what we want to do? We want to add heat. That process is called as fusion. Fusion of solids into liquid. If we actually, what is happening when we are adding heat? How it becomes that liquid? You know, in solid, these particles are closely packed, isn't it? Closely packed. Whenever we are adding heat, what is happening? This distance between these molecules, okay, each water molecules, the distance between that will increase. Understand? When we heat a solid, this distance between each particles, it will try to increase, and at a particular point that distance will be maximum and it reaches this particular distance. Understand? When the distance between the particles of solid increases, it will become liquid. Again, we heat means again the distance between the particles of this liquid also will increase. If we are heating it again, what will happen? Again the distance increase. At a particular point, it will reach us equal distance like gas. Then the liquid is changed into gas. At the same time, what is happening if we cool things down? If we cool gas, that distance between the particles, it will reduce. At a particular point, it will come to, it becomes liquid. Understand? If we again decrease the temperature at a particular point, the distance will reduce to minimum and it will become solid. Understand? It's a simple explanation for how this state of matter is changed. If we add heat, the distance between the particle increases. At a particular point, it will become liquid, and after that, even if we are increasing the heat at a particular point, it will become gas, and in reverse also it is same. Okay. For example, if ice is heated, it will become water. Water is heated, it will become water vapor. Water vapor, if we cool it down, it will become liquid, and again if we cool that liquid, we will get common ice. A simple experiment is there. I think we don't need to draw it and do a common experiment. Take a vessel, put ice, heat it, becomes liquid, again heat it, becomes vapor. Cool down, vapor will become water, again cool down, freeze it, it will become ice. So there is no need of any extra definition for this. So the first phenomenon is called as fusion or melting. Okay, melting. I told at a particular point. Understand? If we heat solid at a particular point, suddenly it becomes liquid. Understand? At a particular point, suddenly it becomes liquid. Okay? That particular point. In that particular point, the temperature of that solution, the temperature of that matter will be constant, and that temperature is called as latent heat of fusion. See, where is my pin? Here. See my kids? Oh, I accidentally taken that pin. I want to take this pin. See my, see here. This is an important one more question. Okay, latent heat of fusion or latent heat of vaporization. Okay, so if we heat, we are heating solid, and it will come heat as a particular point. That is called as the melting point. At a particular point, what happens? It will start to melt, isn't it? It will start to melt at that particular point temperature, and that temperature is known as latent heat of fusion. Okay? In terms we can derive, if we can say latent heat of fusion as the amount of heat energy required to change 1 kilogram of solid into liquid in common atmospheric pressure. Atmospheric pressure means in common room temperature and pressure. In common room pressure, the amount of heat required to change 1 kg of solid into liquid. Imagine this is 1 kg of solid, 1 kg, understand? 1 kg of solid. The heat required to change this solid into liquid, that heat is called as latent heat of fusion. So what is latent heat of vaporization? The heat required to change 1 liter of water, isn't it? So why I use liter here, not kg? Standard unit of volume is liter, isn't it? And mass is kg. In the case of solid, we are using mass. In the case of liquid, we are using volume. Okay? So latent heat of vaporization is the same amount of heat required to change 1 liter of water. Not water, whatever liquid it is. 1 liter of liquid to gas. In the case of water, when water vapor changes to water changes to water vapor, that particular heat. And for water, what is it? It is 100 degrees Celsius, isn't it? Boiling point. And what about this? After which degree this water becomes ice? 0 degree. So latent heat of fusion is above 0 degree for solids, water, and latent heat of fusion is above 0 degree for water, and the latent heat of vaporization is 100 degrees Celsius for water. Okay. So the changing of liquid form, the solid form into liquid is also known as fusion. So come to this part. This is interconnecting or interconversion of these 3 different types of states. So I have here solid. We'll make it a box so that you can see it very well. And I have gas here. And where is my liquid? Okay, liquid also is here. Understood? Solid, liquid and gas. So in this case, I have solid. In this case of water, we can say this is ice, this is ordinary water and this is water vapor. So if I want to change solid into liquid, solid ice into water, what should I do? Tell me. What should I do? Just I must increase the temperature. So it will fuse and it will become liquid. Solid will fuse to become liquid. Liquid again if we heat. When it comes to, in the case of water, when it comes to 100 degrees Celsius, it will vaporize and it will become gas. That process is called as vaporization. Okay. Definition for each of the things you must study. Okay. Solid when heating changes into liquid. That process is called as fusion. And liquid, when we cool it down, it will become solid. That process is called as solidification. Solidification means to become solid. Liquid, when we heat, it will become gas. That process is called as vaporization. And gas, when it cool down, it becomes liquid. That is known as condensation. I think you studied that in water cycle. Condensation of water vapor to change it into rain, isn't it? So, when solid is changing into liquid, it is known as fusion. Liquid is changing back to solid, it is solidification. Liquid is changing into gas, it is vaporization. And gas is changing back into liquid, it is condensation. But in a particular situation, there is an example in the textbook, I will say. Have you heard about camphor? Camphor. I think we are using that thing in temples and all, a white small thing. If we burn it, if we light it, it will burn. Understand? First, have you seen that camphor will melt into liquid form? Then it becomes gaseous form. Am I right? But there is a particular type of experiment. In that, what we want to do? We want to take a small plate. Okay, this is a small plate. Am I right? This is a small plate. And here we are putting those camphor particles. And we are keeping a funnel here. Funnel. You know what is a funnel? Am I right? Okay, you are keeping a particular funnel here. You know what is this? Is a funnel. Okay? You cover that plate with that funnel. And here what we are doing? Here we are adding some flame. Okay, from a candle. Or what all things we have. This is the stand. So what will happen? This we will close this with cotton. Okay, this is a piece of cotton. This is camphor. We are heating it. So here in this case, what is really happening? Any idea? Tell me. And this camphor is also known as ammonium chloride. Okay? Tell me. What is this? What is happening here? We can see that if we are heating camphor without the presence of air, what will happen? It won't change it into liquid. It will change into gas. Understand? So in this case, what is happening? Ammonium chloride is heated, it changed into its vapor form. Directly vapors are formed. Okay, directly vapors are formed. There is no formation of liquid in this equation. So from this equation, what we can understand? Another process is there to convert solid directly to gas. That is called as sublimation. Understand? Sublimation is if we convert solid into gas directly. That process is called as sublimation. And if we are changing gas converting gas into solid, that process also is known as what? Sublimation. So these are the 5 different processes we want to study in this chapter. Fusion. Conversion of solid into liquid is called as fusion. Solidification. Conversion of liquid into solid is known as solidification. Vaporization. Converting of liquid into gas is known as vaporization. At the same time, condensation. When gas is cooled down and it changes into liquid is called as condensation. One more process is there when solid is directly changed into gas. That process is known as sublimation. And when gas is again change it back to solid, that process is known as what? Sublimation. So these are the main process which you want to study. I think it is simple, isn't it? Simple, simple. Anyway, one mark questions are there. Just read that note, you will understand that. So in this part, very important one is this latent heat of fusion and vaporization. Latent heat of fusion is the amount of heat required to change 1 kg of solid into liquid at atmospheric pressure. Latent heat of vaporization is the amount of heat required to change 1 liter of water into water vapor. Understand? Not vapor, water vapor, whatever liquid it is. Even if it is any other honey, if we are changing into vapor, that is also latent heat of vaporization for that particular liquid. Understand? So, and one more thing is that the standard unit of temperature is Kelvin, represented by the letter K. Standard unit of temperature. Understand? And 1 Kelvin is equal to 273 degrees Celsius, isn't it? Or 0 degree means 273 Kelvin. Okay, let's see what we will discuss about that. Okay, I think most of this part is being finished. We'll see what is remaining in that chapter. Okay, next one is the effect of pressure on gas. It's only a symbol. Only a small part is remaining. After that, we will finish that chapter. So, what is the real effect of pressure on these gases? What will happen? So, 2 or more portions are there. Okay, fine. What is the effect of pressure? I think this here some pressure it worked because we sealed that camphor from the atmosphere. So there is no air inside. So directly it is becoming from solid state to gaseous state, and that process is called a sublimation. Any doubt? Okay, fine. So I think we can finish it. Almost time is over. Next class we will discuss about the effects of pressure and also one more important part that is called as evaporation. Okay, evaporation of liquid which forms vapors. Okay, bye kids. Anyway, hope all of you are feeling great. This is Midun Raj signing from this part of the world. Corona time. Okay, Corona time. Be safe. Stay at home. Good food, good water, and be safe. Okay. So till then, bye bye my kids. See you soon. Okay. Jai Hind.